If you find the way we did product rule last time really simple, you're going to love the way we do quotient rule this time. Before we even get into the rule, first you need to be able to recognize that it is a quotient rule question. And how are you going to be able to do that? Quotient comes from the word fractions or divide. So if I see a fraction, that's fine. But if I see a fraction with an x at the top or the numerator and I can't get rid of it, I'm thinking straight away quotient rule. Okay. So the minute that there's an x that we can't get rid of at the top and there's a fraction, I'm just thinking quotient rule. The ones over here are not quotient rules, and I'm going to show you why. So if I had y equals 1 over x plus 2, this is to the power of 1, and this can be rewritten as x plus 2 to the power of minus 1, right? And then all I need to do is just chain rule. That's fine. But imagine this. If I didn't have 1 on the top, if I had x on the top, x over x plus 2, can I cancel these x's? No, I can't, because there's a plus in the middle, right? So like this, y equals x over x plus 2, then yes, this is a quotient rule because there's a fraction and I can't get rid of that x on the top. Let's have a look at another example. This over here, if I had 1 over square root 3 minus x squared, this can be rewritten as 3 minus x squared to the power of a half. And again, I can bring it up. So it can be 3 minus x squared to the power of negative a half. And that's just chain rule. Whereas now, let's look at this. If I had y equals x over the square root of 3 minus x squared, can I get rid of the x from the top and the bottom? No, I've got a fraction and I can't get rid of the x, quotient rule. So if it was 5x squared, same thing, I can't get rid of it. So I'm thinking quotient rule. What about this one? Y equals x brackets x plus 2. If I look over here, I can cancel the x plus 2 with the x plus 2. So I end up with just y equals x. And if I wanted to differentiate y equals x or just x, I'll just get 1. So I can do that. However, what if it looked like this? Y equals x plus 2, same thing, over x plus 3. Can I cancel my x's out? I can't. So I'm thinking quotient rule. If I were to rewrite this, I could factorize out the x. So I can end up with x brackets 2x minus 3, all divided by 2x minus 3. And think I can cancel these two out. So I end up with just an x, which is just normal differentiation. But if I had, for example, 2x minus 5 over here, I wouldn't be able to cancel it out. So then it's quotient rule. Let's just quickly have a look at a few other quotient rule questions. X over x plus 2, we said can't get rid of the x's. It's a fraction, so it's a quotient rule question. X squared over x plus 4. I can't get rid of this x squared by cancelling it out with anything in the denominator, so quotient rule. Now be very careful with ln x, especially if you've just started to learn about ln x. Can I cancel this x with that x? No. Why not? Because the x is attached to the ln, so I can't cancel it out. Another example, a weird looking one is that one over there. Oh, why so big? Get out. Actually, this is quotient rule, and then is quotient rule. So if you